Hey guys, so this is transformations. So when we're looking at transformations of our function, when it's exponential a times b to the x, we still have the same transformations, but they do look a little different. So for the first one, this is step one. This is where our function is equal to our base, and then we have x in the top, and you either have a plus or you have a minus. And then you would have some point, we'll just keep it as h. So remember, a plus h means you're moving left, a minus h means you're moving right, okay? So what this looks like is you have f of x, we'll say the base here is 4. If we have x minus 2 in the top, this means you're moving right 2. If you have plus 2 in the top, this means you're moving left 2, okay? So then the second one you're going to do, second step, is reflect over your y. So what this looks like is when you have f of x and you have your base and you have a negative up with the exponent. Okay, so our negative exponents, this is why you reflect over y. This is why we talked about it in part 1. The negative exponents create that reflection over y. So you've seen this before. This is not new. But the example, we're going to stick with our base of 4. So if I have 4 to the negative x, just like that, that means I have a reflection over your y, okay? So let me write that a little bit nicer. So reflection over y-axis, okay? So the third thing to take a look at, this is again the order that you should be taking. If I have f of x equals negative b to the x, so the negative is out front. So this is where here a would be negative here. So when you have a negative out front, that's your reflect over x. So we're just going to continue f of x equals negative 4 to the x. So what this really is negative 1 times the base of what you have, and that's your reflect over your x-axis, right? So now the fourth thing, and this doesn't really affect exponentials that much, but I just want to make sure we talk about it. If you have your function, and this is where we have an a, okay, we for sure have an a here. If a, you have a fast increasing exponential function. If a is between 0 and 1, it's going to be a slow increasing or decreasing. So slow incline, right, because of the fraction. So what that would look like is if we just kept doing what we're doing. So if we had 2 times 4 to the x, that would be your fast increasing, because you're multiplying by a bigger number, so it's going to increase faster. And then if we brought in a fraction, so 1/2 times my 4 to the x, the half, the fraction, because it's a fraction, you're really dividing. So you're cutting all of these values by dividing by 2. Okay, so that's why it's a slower incline. Okay, it's a slower incline or, decline depending on what b is. Okay. And the last one is your shift up and down, your vertical shift. So if you have f of x and we have b to the x, so if we have an a, that's fine, but we're going to leave it alone. And then you have plus or minus some number, and we'll leave it as k because that's what you're used to seeing. So here, if we left our function as 4, we would have 4 to the x, and we'll just say minus 1. That means you're going to go down 1. Okay? Just like your transformations have always been. Okay, that's no different. Okay, the steps are still the same, the process is still the same, except now we have exponentials. So I want to take a look at example 3. We're going to follow our steps and we're going to graph. We're going to use the regular function of f of x equals 2 to the x. That's going to be kind of our parent function to work from. So we're going to sketch that and then sketch the transformation. And we're going to name the transformations that's happening. So for part A, again, you still have a horizontal asymptote no matter what, and the horizontal asymptote travels with the graph. Okay, so if you move up, down, wherever, it moves with your graph. So my parent function, and this is what we're going to graph first. I'm going to put it in black. It always has the anchor point of 0, 1. Sorry. If you need to do a table, you can. So when you have, because there's only some of these you can graph. So if I have an input of 1, 2 to the 1 is 2. Input of 2 to the 2 is 4. Input of 3, 2 to the third is 8. So we have a couple points we can graph if we want to have extra points to look at. 5, 6, 7, 8. Okay, and then your graph should be going this direction. Okay, so that's our starting graph, and we should always make sure we have that. So then the graph I want to look at for part A, we have g of x is equal to 1 plus 2 to the x. So this isn't in the form that you're used to seeing, so if you need to move it, okay, as long as the signs are correct, you're okay. The base 2 is positive, the 1 is positive, so you just switch the order. So what's happening here is you are shifting, not down, you're shifting up 1, okay? So we're going to use our anchor point, and this is where the anchor point becomes really crucial. And if you have other points, you can do this as well. But the anchor point, if you don't have anything else to work with, will kind of help you move stuff. So I'm focusing on this 0, 1. I'm moving it up 1. So I'm going to move this up 1, that point, and I'm going to bring the other ones in because I have them. It doesn't change the graph too much. And then this horizontal asymptote moves up 1 as well. So I'm going to put a new dotted line 1 unit above before I connect my dots. And then connect my dots that I have for my new function. So it doesn't look too much different. It would be more significant if we had a different number other than 1. But your asymptote moves. So asymptote moves 2. Okay, make sure you don't forget that, because if you forget it, then your graph is going to be wrong. Okay, so let's take a look at B. Again, our original asymptote is in there at y equals 0, and then our parent function we're working from is the same because it's base 2. Okay, so I'm going to put in the same points that we had in our last problem just so I'm consistent, and you should do that too. Okay, so this is our original function f of x. So now I have this negative out front, okay, which is a reflect over my x-axis. Okay, it's out front, so remember inside y. If it's inside with the x, it's a y. So it's in front of the base, which means we're shifting down over the x-axis. So here, all my points are just going to be reflected kind of like a mirror. Okay, so I'm just going to go through 5, 6, 8 and just make sure that they are reflecting the points I already graphed. My horizontal asymptote, because it's the x-axis, actually stays there. It doesn't move, so I'm just going to put the little dots over it so you can see that it's staying with that function. And then my anchor point and the other points I do have, I just plotted those and connected my dots. So that's what that looks like when it's reflected over your x-axis. So then our last one that we have is part C. We have 2 to the x minus 1. We need to put our parent function in. Okay, so horizontal asymptote all the time. That's how you start. Same points that we've been using. Okay, so once you have your points, connect your dots just like you have been. Okay, this is that first f of x. So now with k of x, we have a minus 1 up top, with the X, so that means we're moving right 1 unit. So we're going to take the points we have, this anchor point and anything else that we have, and we're going to move it, the whole thing, 1 unit over, okay? And because it's a left-right move, the y-intercept, not the y-intercept, the horizontal asymptote here at y equals 0 does not move because you're just shifting left. So we're just going to connect our dots and graph our additional asymptote, and then that's k of x. Okay, so the main thing is you need to see, what you should notice here is that the horizontal asymptote only moves when you have a vertical shift. Okay, so make sure that if you have a vertical shift, you are moving that. Okay, don't forget about it. So the next thing I want to talk about, I guess there's not a next thing. So my video is a little short. We'll pick up in the next part. Okay, let me know if you have questions.